Day 5 of 14 videos in the last 2 weeks before the May CFA Level 1 window opens. And today's concept that we're going to hit is Macaulay duration. Going to try and make it short. We'll do another duration in the next week or so just to tie all these together. But what I want to do here is just convince you that Macaulay duration is nothing more than a weighted average and is fairly simple if long-winded to calculate. As I say, we'll do another video where we go through, okay, how is this used? How does it relate to modified duration and go from there? But for the minute, let's just calculate it. We have in a box here our inputs. It is a 5% coupon, that's always stated annually, and 2 payments per year. So we have a semi-annual bond paying a coupon of 2.5, assuming a face value, so future value in your calcs of 100. Yield is 6.1. Again, quoted annually, that means IY of 3.05 if you're going to value it. 4 payments remaining, so N is 4, 2 years or 4 semi-annual periods. Coupon period is 180, so clearly we're doing a 360 here just to keep it simple. So the first thing you can do, and I'm not going to do it for you, I'm sure you're eminently capable, is price this bond. Get on your TVM. There is your payment of 250. There is your IY of 305, N of 4, FV of 100. Compute PV. And what you'll find is the PV of that bond is 97,958. Do a logic check. Coupon rate of 5 is below the yield. Therefore, it must be priced at a discount. So 97,958 checks out. I said Macaulay duration was a weighted average of what? Well, it is a weighted average of the PV of cash flows. So we're going to look and try and find out the weighted average time until the PV of cash flows is received. So let's start with a much simpler example than the one we've got. Let's start with a 0 coupon bond. A 0 coupon bond, let's say that matures in 4 years, gives you 1 cash flow at year 4. That's it. So if you were calculating the Macaulay duration for a 0 coupon bond, the MACD is quite simply equal to its maturity because every single piece of the PV of cash flows is received in one go at maturity. The difference for a coupon paying bond is that we get cash flows at each coupon date. Specifically here for a 5% coupon, so 250 every period, each 6 monthly period, we get a cash flow at T1, 2, 3, 4 of 250, 250, 250, and then at T4, we get our 250 and our face value back. So the total of all of the cash flows you get is $110. The $100 and the 4 250s. But of course, that's not the price of the bond, is it? Because the price of the bond is the PV of those cash flows. So let's work out the PV of every one of those individual cash flows. First off, 250 comes in at T1. Well, if we get 250 in 1 period's time, we are going to discount at the yield 1.0 and be careful, 305. This is annual. We're dealing with semi-annual periods. Discounted at 3.05, you will get a PV of 2.426. Divide that second 250 by 1.0305 squared, and you would get 2.35 and so on. So this is simply the PV of the cash flow received at every date. Add them up, and you should get the non-too startling answer that the total of all the PV of cash flows received is equal to the price of the bond. Well, of course it is, because that's what the price of the bond is. All our calculator is doing when it does this is a sped up version of this. It's calculating the PV of all those flows for you and adding them together. So in total, the PV of the cash flows we get is the price of the bond, 97,958. All we've done here is say, okay, when do we get them? Now, if I know the PV of cash flows and I know the time they're received, I can calculate the weighted average. How? Well, step 1, calculate the weight of PV of cash flows you get at each date. So at T1, we get 2.426 PV of cash flow, $2.426 in PV terms. What percentage of the total bond price is that? That's what this weighting is. So just to calculate it down here, we get 2.426. That's PV dollars out of a bond price, a total PV of 97,958. That is 0.0248 or 2.48% of my total PV, my total cash flows. Do the same for the cash flow at time 2 and you'll get 0.0240. Do the same at time 3, you'll get 0.0233. And then look at time 4, 0.9279. 92.8% just about of your cash flows come in at maturity. Why? Because this is a non-amortizing bond, just coupon, 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 and then all of the principal and the final coupon. Now I have all the information I need to calculate MACD. I know that 2.48% of my cash flows came in at period 1. To get a weighted average time, I'll just multiply it by period 1. That gives me 0.0248. I know that 2.40% came in at period 2. That will give me 0.048. I know that 2.33% came in at period 3. That will give me 0.0699. And that 92.79% came in at time 4. That gives me 3.7116. To get the weighted average, add them together. That gives me 3.8543. The answer is in periods. That tells me the Macaulay duration for this bond is 3.8543 periods. The average, the weighted average time until I receive the PV of cash flows is 3.8543 periods, but that is based on these 6 monthly periods. The examiner is likely to want that annualized. How do we annualize to go from 6 months to annually? Well, do not multiply it by 2. Remember, these periods that we've just calculated are 6 monthly, semi-annual periods. If I want to quote that in years, 3.8543 periods, if they're 6 monthly periods, divided by 2 gives you 1.92715 years. Macaulay duration is typically quoted in years. If you calculate it using semi-annual periods, you must divide by 2 to quote that as an annual figure. That simply goes through piece by piece how to calculate it as a PV so you understand what it is. As I say, we'll do another video to go through what it means, how we use it, how important it is.